Let us start by finding out which of the two is weaker. Is it the gear or is it the pinion? So I'm going to find out this quantity sigma times y, where sigma is the allowable strength and y is the form factor. Okay, first let me find it out for the pinion. Okay, so this is going to give me 120 into 0.09, which comes to 10.8. Now let me do the same thing for the gear. So I have sigma g into yg equals 100 into 0.115, which gives me 11.5. Okay, so we see that the pinion is weaker. The pinion has a smaller value, so the pinion is weaker. The pinion is weaker in this case, right? Okay, so we need to design for the pinion. Now we have been given some torque, which is power, which has to be transmitted. So I can write that the torque is power divided by pi d n by 60. Okay, power by velocity gives you torque, and that should be equal to, let me just write out the formula, sigma wm into y into cv into pi. So here sigma is the allowable strength, w is the phase width, m is the module, y is the form factor, cv is the velocity factor, and pi is the standard value. So if we make us, now in this everything is known except for w and m. Now w is given as 15 times m, so substitute for that, and you know everything else. Now find the value of the module from here. If you solve this, you will get the module as 5.72 mm. Usually the practice is to give the module in as a whole number, as an integer, okay, as an integer number. So this generally is written as about 6 millimeters, right? So that is the required module.